this lecture. That is big analytic historical thing. Okay, this is our second lecture. So we have studied that what is big data is, and now we will study how this big data will came and the problem that came with this concept, how that problem will be resolved. What framework is made to resolve the problem of big data? That all concept we will study in the historical preview. And in this, we will also study how the name will be there in a market that is a Hadoop. Okay, who will that framework, okay, that we will study, and how the name will be invented, that is good. And further, their ecosystem, their environment, their component will be studied. Okay, okay. I will check it.
Okay, good afternoon once again. And today we will study the concept of big data, and it's a historical preview concept we will study. In this, we will go for a what is Hadoop, okay, the framework of Hadoop, and why the name is given to this framework, that is Hadoop, that we will study, and who is the developer of this framework, that we will study, and further the different ecosystems, that is a environment of your Hadoop. That concept is in our syllabus, that concept we will study, and the framework that will be used in your Hadoop. All that concept we will study in our today lecture. Okay. First of all, your big data, why this concept came, what problems are there in big data, that we will study. In the year 2002, Google faced the problem of storing huge files automatically on its servers. Okay, there is a problem, and Google is a organization, and this Google organization faced a problem in 2002, and that problem is storing of a huge files from their servers. Okay, and also performing an analytics, that is analysis on those files. Okay, you will know that there are nowadays there are different types of applications. More than 30 applications are developed by the Google. Okay, there is a Google Map, there is a Google Classroom, there is a Google Form, and there is a Google Translate, Google Meet is there, and so many application of Google. And they face a problem of storing that files on their different servers, and also analyzing that different files on a different servers. And first problem that Google faces, Google, after facing that problem, Google wrote a white paper, that is an type of a complaint. Okay, Google wrote a white paper, and that white paper is a formal technique to write a complaint, and it is a report or a guide that informs reader to solve a problem. Okay, a white paper is a type of a report or a guide that informs the reader to solve a problem and make a decision on that. Okay, and the problem that he is facing is a Google distributed file system. Okay, the problem Google is facing is to storing a file on his file system, and they have a different servers, and the different servers have a different file system. So the word is used here, that is Google DFS, that is Google Distributed File System is there. And to store the data, that is a huge data on the different servers, is a problem that occur in 2002 that Google faced. And he also wrote a white paper to solve that problem. Then there is a developer, and you can see that a scientist is there, that the name of the scientist is Doug Cutting. A researcher is there, the name is Doug Cutting. Doug Cutting, a search framework developer. Okay, he is a researcher and he is working on a framework, and he is a framework developer, was also working on distributed file system. Okay, the Yahoo hired Doug Cutting in 2002 and 2003. Okay, Yahoo, Yahoo is also an organization, and initially Yahoo hired the Doug Cutting, that is a researcher or a framework developer who is working on distributed file system. Google write a white paper report to solve his problem of storing and analyzing the file system, so that after that the cutting took 2 years to fully implement this distributed file system and name it as a Hadoop. Okay, initially Yahoo is hired the Doug Cutting, that is a scientist or you can say a researcher who is already working on a distributed file system. And when Google faced the problem of storing and analyzing the data on her different server, then he writes a white paper to a Doug Cutting. And Doug Cutting will resolve that problem by making a framework, and that framework name is Hadoop. Okay. Yahoo implemented Hadoop as a framework in its full-fledged production environment. Okay. Initially, your Yahoo, Yahoo organization hired the Doug Cutting, and Doug Cutting is working on a framework. And while he's working on a framework, that is a distributed file system, the name is Hadoop, and Yahoo is the owner of that framework because the cutting is working under a Yahoo. Okay. So Yahoo implemented a Hadoop as a framework in its full-fledged production. And after few years, Yahoo donated a Hadoop framework to Apache. Okay. And Apache is also an organization that produce or develop an open source software. Okay. You will use these Apache softwares like Apache Hadoop, Apache Yarn, or Apache HDFS. Okay, these all are the open source software that we will use free of cost. Okay, we have to sign some type of agreements, license agreements are there, but they are providing us. Okay, Apache is providing us open source software. So later Yahoo organization donate that Hulu framework to Apache, and it become a full-fledged project on a Apache. Okay, you are using your Apache Tomcat, Apache web servers are there. There are so many software that are handled by your Apache organization, and these software are open source software. Okay. Further, second problem that arises is Google published another white paper known as Google Map Reduce algorithm. Okay. This is also a problem arises to map your data. Okay. To map your data and then reduce that data in a small blocks. Okay. For that, there is an algorithm named map reduce. And the second problem that raises to a Google, that is to there is a failure in mapping of data in the Google servers. Okay, for that, Google published another white paper, means it generated another report. That problem is a Google map reduce algorithm is not working on that. Okay, because your data become huge in volume. Okay, the concept of big data is there. Then duck cutting and Yahoo implemented this into its own solution as a full-fledged production environment and donated it to Apache. Then duck cutting and Yahoo again make a framework, okay, make a software that resolves that problem of map reduce. Okay, and there is a software, or you can say that there is a concept of a map reduce in your Hadoop also. Okay, the another environment that is added to your Hadoop is also a map reduce concept is added. In your Hadoop, there are map reduce, there is your Hive, there is a Scoop, there is a Hadoop that distributed file system is there. Okay, there are many more in ecosystems that are combined and make a huge software that is a name is Hadoop. Okay, then to resolve this type of Google Map Reduce algorithm problem, Hadoop make a framework. Okay, this is a framework map reduce structure. Okay, you have a data that is unstructured data, and volume is a large volume of data. Okay, this is the large volume of data and the computing cluster, and this is your software that is a map reduce software is there. This software will reduce your the huge volume data and get mapped. Okay, the function of your map reduce is this will distribute the data. Okay, distribute into your different blocks, that is block one. Okay, distributed file system of block one, distributed file system of block one, distributed file system block. This is a cluster one, that is your block one cluster. And here this is your block two cluster. And here you have a block three clusters. And these are distributed to different servers. Okay, to, to resolve this, to analyze this data, and then map these data and reduce the overload. Okay, that is why the name given is map reduce. Okay, this is the environment that is used in your Hadoop. The concept is map reduce, means you will distribute your files to different blocks, then map them together to reduce the overload. Okay, then the analyzing should be there, the selected data should be produced, and that should be your result. Okay, this is the concept of map reduce, and it is a framework of your Hadoop. Okay, the map reduce is your framework of a Hadoop. Then further, a brief history of your big data. The set of storage and processing methodologies commonly known as big data. Okay, Hadoop is used to store your data. Okay, the simple definition is Hadoop is used to store your data, and a huge volume of data is stored at a different nodes. If I am talking about nodes, mean that is on different servers. Okay, then at that different servers, we will analyze that data. Okay, we will analyze that data, and that analyze will be performed by a different framework. Okay, that analyzing should be performed by a different framework, and from that different servers we will collect the selected data and placed at a single server, okay, at a main server. Then we will again distribute that useful data to our nodes. Okay, this will reduce your overload of a single server. Okay, this will reduce because we have distributed the data on different servers. Then that on that different server, we will again analyze the data. Then we will select the data, and then that selected data will be placed on a single main server. And from that server, this valuable data will be distributed to a different location. Okay, like this, your big data or your Hadoop will work on your concept of big data. The set of storage and processing methodology. Okay, storage and processing methodologies commonly known as big data emerged from the search engine provider in early 2000, and it is principally a Google and a Yahoo. Okay, these are the two organizations, Google and Yahoo, who will work on a big data concept. Google and Yahoo. Okay, the search engine provider were the first group of users faced with the internet scale problem, mainly how to process and store index of all the documents in the internet universe. Okay, these search engines, Google as well as Yahoo, these are the both are the search engines that face the problem. Okay, what type of problem? Your data storage. Okay, your data storage problem. Then to analyze that data, okay, that problem erase, and to resolve that problem, the framework that is developed by a duck cutting, that framework is your Hadoop. Okay. Next is your in 2003, Google released a white paper called the Google File System. Okay, that is Google Distributed File System is here. In 2003, Google released a white paper. Means he released a report to resolve the problem of file system to store the data. That is a huge data on the different servers. And in 2004, Google released another white paper called MapReduce. Okay, first is phase storing of data problem, then he will face a problem of mapping of the data. Okay, and that concept is a MapReduce. MapReduce is used to simplify the data processing on a large clusters. Large clusters means a different node. Cluster is your different servers. If I am talking about clusters, mean they are different nodes or they are different servers. Like a Google have a different servers, okay, at a different location. It is have a server in India, New York, okay, then USA, then in Australia. All these countries have its own Google server. Okay, all the data should be stored on different servers of their locality. Then that servers analyze that data, and the selected data should be produced and distributed to the further system that are connected with them. Okay, the same way your Facebook is working on. And further, there is second problem that is of MapReduce. Okay, because your data is becoming in a huge volume day by day. Okay, from if we are talking about from 2002 to till now, your data will become a huge in volume. Okay, to resolve that, the framework is developed. That is a Hadoop framework. At the same time, a Yahoo duck cutting was working on a web indexing project called Notch. Okay. When Google facing that problem, Yahoo owns a developer, then developer name is Doug Cutting. He is already working on a distributed file system, and that project name is Notch. Okay. The Google white paper inspired Doug Cutting to make the work he had done to date on the Notch project. Okay. And that is a project name is Notch, but the concept is of your distributed file system. Okay. He's already working on a distributed file system. He incorporated the storage and processing principles outlined in these white papers. Okay. When Google's write a white paper, he go through that papers or that problem, then he incorporated with them and produce a product. Okay, produce a product, and that product is the resultant product is what is known today as Hadoop. Okay, the product name is Hadoop. Hadoop was born in 2006 as an open source project under the Apache Software Foundation licensing scheme. Okay, initially the owner of Hadoop is Yahoo. Okay, after that, Yahoo donated this software to Apache, and in 2006, as an open source project under the Apache Software Foundation licensing scheme. It is denoted to Apache Software Foundation license scheme in 2006. Okay, now it is open source. Now I can also install this. You can also install this without any cost. Okay, Apache will give you a software without any cost. Okay, and the organization name is your Apache Software Foundation license. Then around the same time as the birth of Hadoop project, several other technology innovations were afoot. Okay, new innovations arises, and these are the rapid expansion of e-commerce. E-commerce is your online business, online shopping concept, online applications are there. Okay, your social medias are there. The birth and rapid growth of mobile internet is there. Blogs, user driven web content are there. YouTube concepts are there. Okay, blogs are placed. There are near about 1 lakh of blogs in a 60-second nowadays. 1 lakh of blogs. Okay, then there is the social media. This is the new innovations. There is a e-commerce concept is added after 2006, and there is a mobile interneting is there. Almost everyone in India now are using a smartphone. Okay, they are using internet, they are using Facebook, they are using Google. If they are using that, means they are producing some more data. Okay, and for that the birth of Hadoop is there. Okay, together these innovations lead to what is known as data deluge. Okay, data deluge is your the amount of new data generated surpasses the limit. Okay, data deluge is the amount of new data generated surpasses the limit. Out of limit your data is generating in a second. Okay, and there is a difficulty to manage it and make it difficult for analysts. Okay, for analysts to analyze it. And data deluge is a term used because there is a huge data is generating in a second. Okay, if there is increase in data, then there is a problem to analyze this data. Okay, to resolve this problem, there is a environment is added to resolve all these concepts. Okay, the name of the project or a software that will resolve this problem, and the name is your Spark. Okay, we will study the next line. There is a concept of Spark. This accelerated the expansion of big data movement and lead to the emergence of another related project such as Spark. Okay, to resolve the problem of data deluge, means to analyze that data, the project is made. Okay, and that project is your Spark. And this Spark is also a product of Apache. Apache Spark is an open source unified analytic engine. Okay, Spark is your open source and it is an analytic engine for large scale data processing. Okay, remember the name is Spark and it is an analytic engine to analyze the data. Okay, data that is distributed on different file systems. Okay, each and every file system have a product that name is Spark, and this product is used to analyze it and select a valuable data so that it can be distributed further on this different systems. Okay, so Spark is an open source messaging system and no SQL platform is it is. Okay, it is a Spark that is open source, but no SQL platform is needed. No SQL queries are used in this. Okay, next is your Apache Software Foundation. Okay, the product Apache, all the open source product, if you want to download, you can visit the website of Apache. Okay, you can download these products free of cost. And that foundation that provide you these open source softwares are Apache Software Foundation. Apache Software Foundation is a no-profit organization. Okay, it is a no-profit organization. It came into existence in 1999. It provides an open source software structures and framework for developer to contribute to process projects, encourage collaborations and community involvement, protecting volunteers for litigation. Litigation is your action taken for your legal project. Okay, litigation means action taken for your legal projects. If you want to develop your legal projects, go for Apache Software Foundations. You can download your software related to that. If you want to collaboration or encourage for community involvement, okay, you can download your Apache software for your different project. If you want to develop any type of project, you can use an Apache Software Foundation to download your software. Okay, and these are free of cost and are open source software. Then Apache Software Foundation is premised upon the concept of meritocracy, and this means that meaning of project are governed by merit. Okay, Apache Software Foundation premised only upon a merit based project. Okay, that project that have a values. Okay, that type of software they provide. Okay, that is a meritocracy. The merit values product is provided by Apache Software Foundation. Next, contributor are developers who contribute code or documentation to project. Okay, here contributors are your software developers. Okay, who will contribute your code, open sources. You can also, as a developer, I can also provide a code to Apache Foundation so that my code, my product can also be used by different user. Okay, I can donate my software also to Apache. If it is merit based, it can be accepted. If it is a normal product, then it can be accepted by rejected by Apache Foundation. So here the word is used contributor. As a software developer, we can also contribute our product. Okay. They are also typically active on mailing lists and support forms. Okay. Apache Software Foundation is also active on mailing lists and your support forms. They provide suggestions, criticisms, and patches to address defects. Apache is also giving his services. They are providing suggestions, criticisms, and patches if there are defects in our product. Okay, they can also resolve that product. Committers are developers who expertise merits, giving them access to a commit code to the main repository for the project. Okay, committer is your same as your contributor. If they can work for Apache, they can also give their product to Apache Foundation. Okay. Next is committer have signed a contributor license agreement. Okay. And here the committer should have a proper contributor license agreement. And then Apache will allow them to give their product to Apache Foundation. Okay. Here computer have a signed a contribute license agreement and have an apache.org email address. Means if I am the employee of any organization, okay, that organization will provide me proper email ID and their agreements. Okay, I have to sign that agreement because I am working under that organization. The same way, if I am the committer or a contributor, if I am working under Apache, then the agreement should be signed with me and an Apache. Okay, and they will provide a proper employee ID, or in your Apache, they will provide an org email address so that they can identify that the committer or the contributor is an authorized person of that organization, and that organization is your Apache Software Foundation. If it is an employee of that product or a committer or a contributor, then he can contribute to an Apache. Okay. Contributor act as a committee to make decision about the project. Okay, if I am the committer or I am the contributor member, then Apache will give the task to the contributor or make a committee of the committers who will decide about the projects that are launched on Apache. Okay, these committer will check whether this software or product is legal or not, it is usable or not. Then it will be uploaded in Apache Software Foundation. Then there is big data analytics solutions are there. Different type of big data analytics solutions are available in market, and these all are the concept used in your Hadoop. There is a Tabula, and Tabula is your visualization tool. Okay, and it is a software of an American interactive data visualization software. Okay, this Tabula is a type of a software. Okay, and this is an interactive data visualization tool, Tabula, and it is mainly focused on your business intelligence. Okay, I will read it again. Tabula is your solution regarding your big data analytics. Okay, and what does this Tabula works? It is a software used for interactive data visualization. Okay, used for interactive data visualization, and it is a type of a tool, or tool, you can say that it is tool or a software, and it's mainly focused on your business intelligence. Okay, then SAS is there. Okay, SAS is a statical computing tool is there, and it is used for advanced analytics, multi varied variate analysis, business intelligence is there, criminal investigation is there, predict analytics is there. Means this is a complete computing software used for your analysis purpose. Okay, multi-purpose concept for analysis there. If there is structured data, unstructured data, semi-structured data, then we will go for analysis on that. Okay, advanced analytic is there, business intelligence is there, criminal investigations we can do according to your SAS product. Okay, then there is IBM and Oracle. Okay, these are also a tools used for your big data analytics. Then there is Evolution, it is also a statistical computing software. Then there is the R, and it is also open source tool for your statistical computing. Okay, all these are your tools, or you can say that these are your software used to resolve your big data analytics problem. Okay, further, there is a difference between your traditional analytics and with your big data analytics. If we are talking about traditional analytics, means we are talking about business intelligence. BI is your business intelligence, and your big data analytics is your regarding your Hadoop. Okay, your predictive analytics is there. Difference is there. First is in your traditional analytics, it is descriptive analytics. Okay, descriptive means you have a data, then on that data you can analyze. Okay, and you have to create a document on that. Okay, description should be there. And in big data analytics, it is predictive, means dynamically you have a data, then you will analyze that data. Okay, dynamic concept is there, no need to create any type of documentation. Diagnose analytic is there in your traditional analytic approach. Diagnosis means first the problem will be there, then you will diagnose it. Okay, but in your big data analytic, data science concept is there. Before erasing a problem, there should be a solution. Okay, this data science concept deals with. Okay, data science is already researching on each and every problem that will arise in future. Okay, the data science is a technique used to analyze your data before they arises. Okay, so the concept in your traditional is diagnose analytic is there, but in your big data, it is a concept of your data science. Means problem will be there, there should be also a solution at the same time. Then in your traditional analytic, limited data sets are there. Limited data sets. Okay, structured data is there in your traditional analytics, in your business intelligence. Cleansed data means structured data is there, formal data is there. Simple models are used in your traditional analytics, but in your data analytics, large scale data sets are there. Big data, huge data is there. More type of data means unstructured data is there, semi-structured data is there. Okay, quasi-structured data is there. Structured data is also there. Okay, that is a more type of data. That different type of data is just structured, semi-structured, and unstructured. Okay, or raw data without any structure. Okay, that is unstructured. Okay, so in your analytics, simple models are used, but in your big data analytics, complex data models are used. Okay, for that we will use different frameworks. Tabula should be there, Spark should be there, to Hadoop distributed file system should be there. Okay, Hive should be there, MapReduce should be there. These all the concept of your big data. But in your traditional analytic, you have only a DBMS, database management system. Okay, you have relational database management. You are using a structured query languages. Okay, but in big data, you have different concepts. Okay, to resolve your problem. And these are working on a live data. Okay, current the data that is producing. Okay, these are the difference of traditional analytic techniques and your big data analytics. Okay, next is your the diagram that is shown. Here is your business intelligence. The diagram with a Venn diagram is there. In your business intelligence, you have a structured data, only structured data. Okay, the point is there. Cleans data means it is a structured data. Okay, a limited data is means you are using a data warehouse and a data marts. Means data warehouse is used where we will place only a selected data only, where we will place only a selected data. Okay, the data warehouse concept is used for storing that data. Okay, and these are used in your business intelligence, that is traditional analytics. Okay, but in your big data there is an unstructured data also, there is semi-structured data also, there is also a structured data. Okay, in your big data concept. And to resolve these big data concept, there is a big data analytics concept. And on that, there is a concept of data analytics. Okay, that is a data science. Okay, data analytics is also called as your data science. And these all are under your knowledge dictionary. Knowledge dictionary means repository. Okay, huge data is there. That all will be resolved by your data science and further your big data analytics. And under your big data analytics there are big data, and that is your unstructured, semi-structured and structured. Okay, further there is a Hadoop ecosystem. Okay, or you can say that environment also, Hadoop environment. In Hadoop ecosystem can be described as a data centric taxonomy to analyze, aggregate, store and report data. Okay, Hadoop environment is used for your data taxonomy that will analyze, aggregate, analyze your data, aggregate your data, store, and also generate a report for your data. That all done under your single framework, that is Hadoop. And in a single framework, there are different environments. Okay, and various component of Hadoop ecosystems are, this various component is your different environments, and that environments are, first one is HDFS. Okay, HDFS is your Hadoop distributed file system. Okay, here it is on your diagram. This is your HDFC. This is complete Apache Hadoop ecosystem. That is your framework in which there are different environments. Okay, first is HDFS, stand for Hadoop distributed file system. Okay, this is used to store your data. Okay, store your data on different clusters, different servers. Okay, then Hive is there, HIV, here it is, Hive. And in this there are SQL queries. Okay, this is also a framework in which you have a SQL queries, and name given to this framework is Hive. Okay, then Pig is there. Okay, Pig is also a framework used to analyze your data. Okay, Pig, name is Pig, here it is, this one. Pig is used for your scripting, means to analyzing your data. Okay, huge data is there, and to analyze the data, the framework that is used to analyze data is Pig, and to store the data, the framework that is used is HDFS, that is Hadoop distributed file system. Pig is used to analyze. These are the two concepts that are in our syllabus in big data analytics. HDFS is there. Okay, and this we will install in our system while performing a practical on Hadoop. we have to install HDFS, Yawn, and Pig. Okay, these are the concept or a framework in our syllabus that we will study. Okay, so keep in mind these names. HDFS is there, Yawn MapReduce is there. Okay, Yawn is yet another resource negotiator. Yawn full form is yet another resource negotiator, and it is a map reduce. Okay, and this framework is used for your distributor processing framework. Okay, then Pig is there. Pig is a scripting. This is used to analyzing your data. Yarn is there. Flume is there. Okay, here it is Flume for your log collector. Okay, this one. Then Scoop is there. Scoop is used for your data exchange. Okay, Scoop. Then Aussie is there. Here is a Aussie that is used for your workflow. Zookeeper is here. Coordination will be maintained by your Zookeeper framework. Then Mahout is there. Okay, that is a machine learning concept. Then there is a Ambry. Okay, here it is an Ambry. It is used for provisioning, managing, and monitoring Hadoop clusters. And further, there is a HBase also. That is Hadoop database. Okay, that is a columnar store. Okay, store is there. And store name is HBase. That is Hadoop database. Okay, further, there are R connector. These are used for your statical mappings. Okay, statical computation is there, and the concept, the name given is R connector. Okay, these are the ecosystems in your Hadoop: HDFS, Hive, Pig, Yawn, Flume, Scoop, Cozy, Zookeeper, Mahout, Ambry. Okay, and in our syllabus there are HDFS, Pig, Yawn. Okay, these three concepts we will study on further unit second and unit third. Okay, and these three ecosystem will be installed while we will perform a Hadoop installation. Okay, when we perform Hadoop installation, we will also install these framework also. Okay, we will perform that practical in our next lab. Okay, further summary is there. Apache Hadoop is an open source framework used for storing, processing large data set. Okay, in your Hadoop framework, Hadoop storing is done by your HDFS. Okay, HDFS is your Hadoop distributed file system. Storing is done by your HDFS, and processing and analyzing is done by a Pig framework. Okay, so Apache Hadoop is an open source framework used for storing and processing large data set on a commodity hardware in a fault tolerant manner. Okay, in your fault tolerant manner. Hadoop was written by a Doug Cutting and Mark Cafrela in 2006 while working for Yahoo. Okay, they are working under a Yahoo, and the developers are Doug Cutting and Mark Cafrela. To Yahoo to improve the performance of Notch search engine. Okay, they are working under a Notch. Project name is Notch search engine. And on that project, they are working on distributed file system as well as on a your map reduce also. Okay, here Notch is also a product of Apache, is a highly extensible and scalable open source web crawler. Okay, Notch, Nuth, it is a project name. Okay, it is a project under your Apache. Okay, next point is that is cutting, that is dog cutting, named it after his son's stuffed elephant toy. Okay, the name given to the framework, that is Hadoop, is came from from his son's stuffed toy, and that toy is an elephant. Okay, the name will be given from that, that is a Hadoop. Okay, in 2007 it was given to the Apache Software Foundation. Okay, in 2007, first of all, it is a product of Yahoo, but after that, it is donated to an Apache Software Foundation. Initially, Hadoop was adopted by Yahoo, later by companies like Facebook and Microsoft, and after that, it is donated to Apache Software Foundation. Yahoo has about 1 lakh CPUs and 40,000 nodes. Means nodes, if we are talking about nodes, means they have a server. 40,000 servers are there. Okay, for a Hadoop, the largest Hadoop cluster has about 4,500 nodes. Okay, and Hadoop is installed on 4,500 nodes. Yahoo run about 8 lakh 50,000 Hadoop jobs every day. Okay, Yahoo runs about 8 lakh 5,000 Hadoop jobs every day. So on Hadoop is on demand. Okay, that is your high job will be in your Hadoop. There are different type of profiles. You can go for your job, your data analytic, your data storing, or you can go for a different frameworks are there, Hive concept. Okay, there is a H-based concept. Okay, that is why there are a different job profiles, and near about 8 lakh 50,000 Hadoop jobs are there. Hadoop follows a scale out strategy, which makes it more scalable. In fact, Apache Hadoop had a set of benchmark by sorting 1.42 terabyte per minute. Okay, means in a 60-second, Hadoop will sort the data. Okay, they can store, they can analyze the data up to what capacity? Up to 1.42 terabyte TB of data. 1.4 TB of data gets sorted in within a 60-second. Okay, this is the capacity of Hadoop to sort the data, to analyze the data. Okay, most of a Hadoop is written in Java. Okay, your Hadoop is written in a Java language. Okay, but it has support for many programming language such as C, C++, Python, Scala. Okay, these are the different programming language used in your Hadoop also, but it is written in Hadoop is written in your Java language. Okay, then RDBMS technology were written for frequent modification in data, whereas Hadoop has been written for frequent reads. Okay, RDBMS is used for your frequent modification of data, but Hadoop has been written for frequent reads. Okay, means predictive data is there. Latest data should be predict, store, and analyze. But in your RDBMS, there is a structured data. First of all, you have to store that data, then analyze that data. Okay, that's all about your historical preview of big data. And further, there are, yeah, Hadoop ecosystem is there. Okay, if you have any question, you can ask me. You can raise your hand. Okay, next concept is if you can ask any question, you can ask me if you want to ask any question. Okay, next is your the concept of Hadoop in detail. Okay, first of all, we have studied that what is big analytics, what problems arises, how big data analytics problems are resolved, what solutions are made, okay, what softwares tools are made to resolve your big analytic problems, and there are further framework is developed. That framework is your Hadoop that resolves all the problem of your big data. Okay, now we will study the further the concept of Hadoop. Okay, what is Hadoop? Okay, what approaches are there in a Hadoop? Okay, what technologies, what terminologies we will use in your Hadoop. Okay, first of all, Hadoop is a data storage and processing platform. Okay, that I have told you that your Hadoop is a data storage. Okay, it is used for data storing and it is used for processing. In your Hadoop, the software that is used for storage is HDFS, that is Hadoop file system. Okay, to analyzing, we are using a pig. Okay, pig framework is used, and these are based upon a concept of data locality. Okay, data locality term is used. What does this mean? Data locality, data locality is the process of moving the computation close to where the actual data is. Okay, data locality means we have to move to up to the data. We will not collect the data, we have to reach up to the data. Okay, that's data locality means. Okay, in simple definition, we will not collect the data. Okay, we will not collect, but according to Hadoop, we will go till data where it is. Okay, we will go up to the data. Okay, हमें डाटा तक पहुंचना है, हमको डाटा नहीं लेके आना. We have to reach up to data, then to collect or bring data on our system. Okay, locality is the process of moving the computation close to where the actual data resides instead of moving a large data to computation. Okay, data को लेके नहीं आना अपने तक, we have to reach up to actual data reside where it is reside. We have to reach up to that location. Okay, that is why the term used is data locality. Data locality is a process of moving the computation close to where the actual data is rather than moving a large data to a computation. Okay, that is a main point used in your Hadoop. Okay, Hadoop enables large data set to be processed locally on the nodes of a cluster using a shared nothing approach. Okay, what does this line means? Example is there, Google have their server, different servers on different location. Okay, Google have their different servers and these servers are the nodes. Okay, they have their different nodes on different locations. Okay, and on that nodes or a server, they are collecting that data. Okay, they are collecting that data, they are processing that data, they are analyzing that data. Okay, that is this line means Hadoop enable large data sets to be processed locally, means they are processing the data locally on a particular location on a particular server. Okay, if it is on USA, it is working on a USA server. Okay, if it is in India, it is collecting the data of India users, analyzing that, processing it. Okay, that is this line means Hadoop enables large data set to be processed locally on the nodes of cluster using a shared nothing approach. Okay, they are not sharing with each other, only they are collecting, analyzing, and processing the data. Okay, on their local positions. Then each node can be independently processed a much smaller subset of entire data set without needing to communicate with one another. And this is the solution that we are working on different locations and analyzing and collecting that data Okay, this will reduce the load. Okay, this will reduce the load, and this is all done by the concept of Hadoop. And on each server or each node, there is a framework installed on that is your Hadoop. Okay, each node are independently process a much smaller subset of entire data set without needing to communicate with one another. Okay, they are performing their work without communicating with any other node. Okay, Hadoop is a schema less with respect to its write operation. Okay, Hadoop is a schema less with respect to its write operation. It is what known as schema on read system. Hadoop's work on schema on read product. Schema is your structure, design. Okay. And Hadoop works on your schema on write system. Okay. What does schema on write means? Create a schema only when reading the data. Okay. Design should be made only while it is reading the data. Okay. That is why it is called Hadoop is schema less with respect to its write operation and its work on schema on read. When it want to read, then only it will create a schema. And schema is just structure or a design. Okay. जब जरूरत है तब ही डिजाइन बनाया जाएगा. While it want to read a data, then only the structure should be made. Means schema should be made. That is why it is the term used is schema on read. And schema on write, what does it mean? Schema on write is designed as a creating a schema for data before writing into the database. कि database में लिखने से पहले हमें डाटा बनाना स्केमा बनाना पड़ेगा, स्ट्रक्चर बनाना पड़ेगा. ठीक है, ये हम अपना डीबीएमएस में करते थे. डीबीएमएस में हमें टेबल बनाना पड़ता था, फिर उसमें डाटा डालना पड़ता था. बट इन योर Hadoop concept, this is work on schema on read. When it want to read, then only it will create a schema. Okay. Next is schema on read system versus schema on write that I have explained recently. Okay. Hadoop works on your schema on read system process. Then there is no SQL platform are classified as a schema on read system that I have explained. In your relational database, first of all, you have to create a data, okay, using your SQL concept. But in your Hadoop, there is no SQL platform is there. Okay, there is only a schema on read system concept. Okay, and for that, the Apache HBase, that is a Hadoop database, is used. Framework that is used to work on your schema on read system, and that comes under your HBase, that is Hadoop database. Okay. Because the schema is not interpreted during write operation to Hadoop, there are no index, statics, or other construct typically employed by database system to optimize query operation. Okay. That is, the schema is not interpreted during a write operation to Hadoop. In your Hadoop, there is a no interpretation of your schema is there when you are writing your operation. Okay, there is no index, there is no static concept in use. So your Hadoop is work only on your schema on it. When it is needed, then only schema is built. Okay, no interpretation concept is there, no indexing is there. Okay, Hadoop is designed to find needles in a haystack. Okay, what does Hadoop do? Hadoop is designed to find a needle. Okay, needle from haystack. Okay, कि एक बड़े डाटा में से एक छोटा डाटा निकालना, वैल्यूएबल डाटा निकालना, उसके लिए हम क्या कर रहे हैं? We are using Hadoop. Okay, and that is done by your done by your data locality and your shared nothing process. Okay, Hadoop works on data locality, shared nothing, schema on read, Okay, and no SQL concept is used. Okay, and according to these concepts, Hadoop is designed to find a needle. A small data should be analyzed, processed from a large volume. That's Hadoop is used for. Okay. Further, Hadoop have a core components that I have explained in the previous presentation. And what components are there? Hadoop has two core components. First is your Hadoop distributed file system, HDFS, and it is used to store the data. Okay, file system. And it is also used to store and process. Then there is a yarn, which is stand for yet another resource negotiator is there. Okay, negotiator. And here HDFS is your Hadoop storage subsystem. Okay, Hadoop storage means data should be stored with which framework? With the help of your Hadoop distributed file system. Okay, yarn can be a thought of a Hadoop process scheduling subsystem. Okay, further there are different. These are your main components, core component. Okay. Okay. Yarn is used for your process scheduling. I will show you your architecture on the board, whiteboard. You can. You can zoom your screen. I will show you an architecture how your Hadoop will work. Okay. And question asked us is what functionality of your name. Okay. First of all, in your Hadoop, this is your Hadoop architecture. Okay. In Hadoop architecture, you have a different map reduce. Different environments are there. Okay. There is a map reduce. There is your HDFS. Okay. Further, here is the your. Okay. And there is also common utilities. Okay. Okay, these are the main frameworks that comes under your Hadoop. First is your MapReduce. This is your MapReduce, HDFS, your and common. Okay. MapReduce is used for your distributed processing. Okay, distributed file processing can be there. Your distributed file processing is done by your MapReduce. Then distributed storage is done by your Hadoop distributed file system. Okay. Then yawn is your performance yet another resource negotiable. Okay, and this is used for your job scheduling.
and your resource management. Okay, your your Yawn is a framework. It is used for your job scheduling. Okay. All the jobs are scheduled by this framework. That is Yawn and your resource management. Okay. If these jobs are distributed to different nodes or a cluster, then the functionality of Yawn is to schedule that job, then also allocate the different resource to their different jobs. Okay, you can say that these are job or task, okay, or processes. Okay, that all done by a job. First of all, schedule that job, then resource manager is also is a functionality of your job. All resource should be managed by your job. Allocate of resources to different jobs is managed by your job. Okay, this is your framework. This is also a framework that is HDFS, Hadoop Distributed File System, and it is used for your storing your file. Okay, distributed storage. Okay? Distributed file storage is done by your this framework. Processing. Okay, processing of your data is done by your MapReduce. Okay, this is MapReduce. It is also a framework. Other common utilities is your Java utilities. Or you can see that these are the Java libraries are there. Okay, Java libraries are comes under your common utilities. Your JavaScript. Okay, that all come under your common utility. Okay, further there is also a playground. This is used for data analysis. Okay, this is used for your data analysis. Data storing should be done by your HDFS framework. Processing should be done by your MapReduce. Analysis should be done by your PIC framework. Your should be used for your job scheduling and resource manager. And your common utilities are there in your frame architecture. And these in your common utilities here you have your Java libraries and JavaScript. Okay, this is your framework of your Hadoop. Okay. The main components, core component are HDFS and Yawn. Next is a cluster is collection of systems that work together to perform a function. Okay, cluster are your collection of system is called cluster. Okay, and all that systems data will be collected at a single server. Okay, and that server is your node. Each component is dependent on one another and can operate in its own cluster. Okay, each component is independent of one another and can operate in its own cluster. Okay, and all that system are connected with the single server, and these system are called cluster, and they are connected with a single node. Okay, and all the data from a different system are collected on a single node, and from that node the main server will collect the relevant data. Okay, useful data. Then HDFS cluster and a Yawn cluster can operate independent. Okay, There is a HDFS cluster also. There is a yarn cluster that operate independently. HDFS work is to store the data. Yarn is to schedule the jobs. To resource managers are there. That is why they works independently. Okay. HDF function is something else. Yarn function is something else. Okay. They are work independently. When they are co-located with one another, the combination of both system is considered to as Hadoop cluster. Okay. When they co-located with one another, the combination of both system is considered to as combination of both system. Then it is called a Hadoop cluster. Okay. Then when they are connected and make a single system, they call that system as a Hadoop cluster. Individual server within a cluster are referred to as a node. The same point I have told you. An individual server within a cluster is referred to as a node. Okay, that server is called a node. And all these different clusters, values or data are collected in a single node. And from that single node, then this data will be processed. Okay, the selected valuable data is further distributed to a main server. Okay, from where they will distribute that data to all the systems. Okay, then any other project that interact or integrate with the Hadoop in some way, or for instance, or data ingestions project such as Flume, Scoop, these are also a framework in your Hadoop, or data analysis tools such as Pig. Pig is used for your data analysis. Okay, or Hive are called your Hadoop ecosystem. Okay, they are talking about that there are different environments or your frameworks that are used in your Hadoop to interact or to integrate your system, and that frameworks are Flume, Scoop, Pig, Hive, and that all comes under your single Hadoop ecosystem. Okay. In many ways, you could consider Spark an ecosystem project, although this can be disputed because Spark does not require Hadoop to run. Okay. Spark is also a software, Apache software used to analyze your data, but it is not come under your Hadoop environment. Okay, Sparks not comes under your Hadoop, but it works same as your Pig. Okay, same as your Pig environment, but it works individually, not come under your Hadoop environment. Okay. Further, there are more ecosystems are there. For data analysis, there is a Spark. Okay, there is a Hive, there is a Pig. Okay, Pig is also there, but Spark is a different software, but it is used for a data analysis, not come under your Hadoop. That comes under your Hadoop is your Hive and Pig. Okay. Further, for data integration is your Flume and Scoop. These are the product of your Flume. Okay. For NoSQL database, Apache HBase is there. Okay. For security, NOC is there. Okay. Further, Sentry is there. For security purpose, NOC and Sentry is there. Okay. These are the ecosystems for data analysis: Spark, Hive, Pig. Pig and Hive is the product of Hadoop. Spark is not a product of Hadoop. For data integrations, Flume and Scoops are used. These are the product of Hadoop. And NoSQL database are your H database and Comblo. And these are the product of your Hadoop. And for security purpose, NOC is there, Sentry. Okay. These are also a product of your Hadoop. Okay. This is the same slide that we have explained, the core components. Okay. This is your all history of Hadoop. How Hadoop arises, how name is given to a Hadoop, Okay, what are the frameworks or environments that come under your Hadoop? The core component is your YAR and HDFS, and there are many more components are there. Okay, Hive is there, HBase is there, Scoop is there, Flume is there. That all are components. Okay, that's all for today's lecture. If you have any question, you can ask. Okay, I will unmute you all. First of all, you will raise your hand, then I will answer you if you have any question.